morning, ladies and gentlemen. My name is Marianna Skylakaki, and I have the great pleasure to be moderating the next discussion on the topic of transforming our cities, paving the way towards urban regeneration and sustainable buildings. Our speakers today, David Nelson, Senior Executive Partner and Head of Design at Foster & Partners, Panagiotis Skiadas, Sustainability Senior Director at Viohalco, and of course, Panagiotis Kapetanakos, CEO of Noval Property. Welcome. It's truly a very interesting combination, and I think we have very complementary insights that we're going to explore in the next 30 minutes. We have a lot of ground to cover, so we'll dive right in. I think a common denominator throughout this year's conference has been sustainability and its impact on various facets of our lives. Obviously, cities, for most of us, form the environment where we spend most of our time. So it is imperative to see what we can do to change the existing situation. But do we really have an idea of what a sustainable building really is? I'd like to start with that question to you, Mr. Nelson, because I wonder if there is a universally accepted description of what a sustainable building is, and what is the current state of play regarding sustainable buildings?
Well, I think it's a very good question. It's also incredibly difficult to answer. I think sustainability is a word that has been used and abused, and therefore has been interpreted by different people to mean similar things but different things, and the tendency to over or under exaggerate, I think, is there. One of the things that's important to us is that buildings in the end are for people, and they reflect and enhance and encourage our own lives and the way we live. 25 years ago, when we used to talk at events like this, we used to start with the fact that if everybody in the world, and every human in the world, lived like an American, we'd need 5 planets in order to be able to make that happen. Europeans were 3, and at the time, 25 years ago, China was just over 1 planet, and India was slightly under 1 planet. And obviously, a lot of things have changed, but one thing that hasn't is that we only have the 1 planet. So what can we do? How is sustainability defined so that we can then bring that back down to the scale of architecture? Well, obviously, the most recent thing, about 8 years ago, with the Paris Agreement coming out, we had a great opportunity to be able to work with the UN in the following year from when it was released, to actually help them do a visual interpretation. It's an incredibly complicated document. It's been put together over many, many different meetings. So to be able to have that opportunity to study the whole elements of everything that's to do with that Paris Agreement, and it touches not just architecture, it touches everything: agriculture, industry, water, ecology, everything through there. And really the biggest message that came out of it was in what's known as Article 2 and Article 4. Article 2, you're all aware of, it's the decision to go for 1.5 degrees. The instruction for all of us is we have to do in our different fields to achieve 1.5 degree temperature increase. There's only 0.5 degree left, and many people, I'm sure, at this conference will probably tell you that we're probably already at 1.5 degrees right now. So that was the targets that were set. And it's all based on emissions. So what we tend to do is we produced about 40 billion tons of greenhouse gases. The shorthand is carbon, but we all know it's made of different things. And we put that into the atmosphere every year. The 1 planet that we can have can absorb 20 billion tons, which leads to this half reduction in carbon emissions by 2030, and then, let's start to work on the overall long-term problem after that. So that really is the guiding light. And just to give you an example about what is a sustainable building or not, we have 2 projects for the same client in the United States. One is in New York, and one is in California on the West Coast. The one in New York is built over railway lines. So the structure has to thread its way through. Quite complicated, quite difficult. It's a tall building. It's part of a bigger complex, but the building is there. There are no parking spaces because the trains are underneath. So that building there with lots of steel in the middle of New York computes out, if you analyze the sustainable factors, particularly to do with the carbon that it's produced, to be a figure that it is. The other project for the same person on the west coast is lower rise, maximum about 5 or 6 stories, timber structure for most of them, very, like good places for people to be. The problem is that there are 3 levels of car parking in that project because it's in California, and the lifestyle of the Californian is to actually drive. In New York, you walk, and you can't drive anyway because there's no car parking. Those 2 projects, when you look at the sustainability value, come out more or less equal, with the tower being slightly ahead. So it's very difficult to pinpoint exactly what a sustainable building is in isolation from those other factors.
It's so interesting, though, because it just goes to show how important having a holistic approach to sustainability is. And I'd like to ask you, Mr. Skiadas, how do materials enter this equation, and how do they impact a building's ecological footprint? And are there technologies that are allowing us to reach this stated goal more quickly in terms of materials in particular?
Okay. Well, following up on Mr. Nelson's narrative, we have to put things into context. And in an effort to contextualize what is a sustainable building and how materials come into play, we have the bad news that buildings are responsible for a very big share, a very big chunk of that temperature rise that we're seeing. Materials are responsible. All the construction materials do have a carbon footprint at the moment, and we have a long roadmap ahead until we can actually talk about materials that are extremely or ultra low carbon. The good news is that the biggest footprint of a building over the life cycle. That's why it's very important that we always look at a building over its life cycle. Does the building operate 24 hours? What is the average temperature we want to have in a building? That will, in a sense, determine what materials or what technologies you want to use. Now, the good news is that operationally, we're there. We can actually achieve either net zero or low carbon operation of a building. We do need the massive deployment of renewables that will electrify everything, and we will move away from hydrocarbons. But to cut the long story short, as far as operation, we would say that it's about 75% of the actual footprint, where 25 is the actual construction. And then when you're talking operation, you have air heating, water heating, cooking, and so forth. So we can move forward in that direction to make living in a building much lower carbon.
So a big part of the equation is what you do after you have built a city, its life cycle. So my question to you, Mr. Kapetanakos, has to do with this idea of repurposing old buildings, because cities, to a very large extent, are already built around us. Is repurposing buildings a part of this vision for a different city that is more friendly to the environment?
Yes, indeed it is. And the reuse of existing building stock is a very valuable strategy towards sustainable urbanization, sustainable development. Because on the one hand, you reuse existing structures. On the other hand, you avoid or you reduce building new. So in that way, you conserve resources. You can obviously reduce carbon emissions associated with new construction, and obviously you reduce waste. So every project or every building that requires redevelopment or reuse of an old building stock is actually an opportunity and also a commitment towards sustainable change, because it's either to reuse all building stock into sustainable assets, or it is to reinvigorate degraded parts of our cities, or to create healthy and modern workspace to the well-being standards of tenants, and obviously address embodied carbon within the built environment. Maybe, a good example of what we're discussing about is the major development that we are progressing at 252 Piraeus Street in Athens. So that's about 72,000 square meters of the former Viohalco industrial site. Indeed, the very first Viohalco factory dating back to the 1930s. It is just a stone's throw away from the city center, but in a degraded part of the city. And we're actually working on the regeneration, the redevelopment. So basically to transform that old industrial site into an innovative, a new, a modern, a resilient, a flexible, balanced use of uses such as cultural, hospitality, office, retail, and residential. And we are incredibly happy that we are working together with Forster and Partners, that they have produced a master plan for this project. And we are using the expertise of Forster's on urban regeneration, because it's a very complex, it's a very difficult subject to regenerate. And we're using their expertise in order to transform this project. And it's going to be, actually, it's a multi-dimensional urban regeneration, because it's going to upgrade, hopefully, and revitalize, reinvigorate, regenerate the entire Piraeus Street, starting from Athens going to Piraeus, and obviously all the society and all the surrounding areas.
It's so interesting that this building back better idea and trying to have a much more sustainable approach also has tangential benefits in terms of economics, in terms of the way we live, in terms of our society. How critical is the existence of standards in this entire process, Mr. Nelson? Because I think it's very likely that our audience has heard about standards like LEED or BREEAM. How do these existing certifications measure up, and do they help us in this direction? And I know that Forster and Partners has a very ambitious methodology to approach sustainable buildings. Could you talk a little bit about that?
Yeah, again, part of the process of looking at the Paris Agreement and making a greater understanding and awareness of all of that, you realize that through research that we did that's led to our methodologies, one thing we were able to do was look at all of the projects that, like LEED and BREEAM, and there are 250 different measurement systems around the world. They're all very similar to them. They're all point-based, basically. And if we literally complied with those standards on every single building built and new, we'd still have a 3-degree temperature rise. So we discovered that in 2016 and immediately spoke to LEED and BREEAM, because we got, what do we do next? What happens next? And they recognized and are in the process of re-looking at it, but it's a complicated system or mechanism to actually change, and they're not even regulations, these are guidelines and things that's through there. I think the majority of our work still follows those systems, and some of them are moving ahead. The French one, the E+ C- is progressing very well and closer towards the Paris standards. For us, the Singapore code is very good. There's an Australian one called Neighbours, which has got nothing to do with their TV program, but is also being adopted in certain other parts of the world. So there's a strong tendency, and that will move on. It's just going to take some time. And we only have, 6 3/4 years left until 2030. So you have a choice. You either sit down and wait for it all to happen, which we find extremely difficult to do, or you put yourself in a place where you've got to go and find something. You've got to go and find a way of actually tackling the problem and getting down to the next levels. And we have found through there, we found that in terms of looking at greenhouse gases produced by our buildings, Michael Bloomberg had made the statement that to manage, you first have to measure. So we have to measure. So what measures are there out there to be able to do it? And interestingly, just measuring components of buildings and thereby allowing you to calculate the carbon, there are quite a lot of different systems out there. We use one from the RICS, we use several actually, but one of them called OneClick. They have been in existence for a while, and you can pretty accurately work out how much carbon is in each and every component. The trouble is, again, from the research that we've done, measuring alone, physically measuring alone, will only give you about 40 to 60% of the actual carbon. So we had to find another way, and we've adopted the software related to carbon footprinting, which has been in existence for 60 years. It's out there. We've adopted it and tried to actually process the process, because it also means that we can calculate the absorption. if you achieve a carbon level in a building, you've also got to balance that with the earth and how much can it absorb. Part of that 20 billion absorption every year we have to do. So that's really what we've tried to do that. But you have to believe us. There's nobody who can come along and give you a rubber stamp and a piece of paper. So we want to explain it to everybody and hope that you'll be adventurous as we'd like everybody to be.
This idea of balancing realistic expectations about where we are at the moment and this goal that seems very much out of reach at the moment that was set in Paris, how realistic is the objective of a net zero building at the moment, Mr. Skiadas, if we were trying to strike this balance between the two, realism and the goals?
Well, I think you chose the right word to be realistic. Because if you read the newspaper and you look at what is out there, you would think that we're already achieving net zero, which is not the case at all. In fact, the goals are so ambitious that we should prepare ourselves for a possible failure. Not because we don't want to, not because there's not the political will, but because there are limiting factors on what we can and cannot achieve over the years. You know, since we said materials are necessary to build a building, you know, anybody who's in the construction of a building realizes you need several materials. And it's not an easy task to decarbonize every single one. There's, you know, an arduous, a laborious process to extract the materials, refine them, bring them in the condition that you want. And the limiting factor is at which pace can we actually do this? Can we actually decarbonize every single phase of the materials coming from Earth? You know, even recycling. Recycling does require energy. Recycling aluminum or construction materials, what have you. So there is an objective limiting factor. And that's why we cannot, you know, we cannot reach what I said earlier, these decarbonized materials like steel and concrete and aluminum. And there will be an associated cost. So on one thing, there's a technology. On the other hand is how much can we actually afford as a society? Will someone be left behind because it will be more expensive to build a decarbonized building?
And I think this part of the equation, the fact that sustainability has a cost, moving to this sustainable world has a cost. Is the market prepared to pay a premium for sustainable buildings at the moment, Mr. Kapetanakos?
Well, first of all, what we're doing is we're educating ourselves first and foremost, and you know we're using the expertise and track record of Viohalco, our parent company, and Forstner Partners, working together with us to understand better and get a better grip of sustainability requirements now, but more importantly in the future, and what is expected, how it's expected to unfold. So having educated ourselves, because you know sustainability is now an essential part of the fundamentals of our business. What we're trying to do is educate the market, our tenants, all stakeholders, whether it's financial institutions, tenants, design engineers, etc. So basically about the benefits of sustainable buildings, whether these are obviously, you know, the reduced carbon emissions and, you know, the lower maintenance and operating costs and the healthier indoor environment, and also the resilience towards environmental and economic and social challenges to come in the future. And we see that, you know, tenants, definitely, you know, multinationals and large Greek corporates, because they also have similar pressure also from their investors, from their financial institutions, from their workforce, and from the society in general, that they demand sustainable, environmentally certified, modern buildings. And we see that, you know, because they have this demand, because, you know, they can address better their corporate values, their corporate identity, they can meet their ESG commitments, they can attract and retain talent, their workforce have a better productivity in terms of their employees. So they're seeking, they have a strong demand. And this leads to higher rental values, higher occupancy, higher capital values. So if you couple all that together with resilience towards the future in terms of risks and changes, so a lower risk profile, so overall there's a premium for these kind of buildings.
But it does make sense if you start putting the future into the picture. Mr. Nelson, we have, I think, 8 minutes left for our discussion, so we'll have to try and be brief. But I'd like to ask you to share with us whether your design philosophy, and you're head of design at Foster & Partners, has changed and evolved in face of the climate crisis, and how does this change fit into the collaboration that you have with Noval Property in Athens?
Yeah, I think that I would say since 2016 we've been trying to focus on finding new ways of doing things in order to achieve it. There is no market out there for it. Nobody will come to you and ask for this. I think it's something that we have to go and show to people and say, are you interested? It doesn't, people don't run to our door saying, please give us a Paris compliant building. I think the whole question of proving whether something works or not is pretty central. We've developed at a certain pace because until we have something complete, there's nothing that anybody can go and walk around. 6 months ago in Madrid, we completed our first, what we believe to be a 2-degree building. That was the target when it was first laid down. And it's a relatively small building. It's an existing building, fitting in with the previous discussions. It's a very old 19th century building that we've kind of reworked and remodeled and changed into office space, which will now be in existence. We have a couple of other, 2 or 3 other projects. One of the difficulties is to find people to work in this way, because it's very complicated and there's no previous training. So the speed that we can implement these things out is quite determined. But we were talking yesterday, I think what we should do, and the project in Piraeus that we're working on together, I think is a really golden opportunity. It's bigger, there's 20 buildings, some existing, some new. Mm-hmm. And I think we're going to do an evaluation together to look at all the possibilities. What can we do? What can we achieve? They won't be all taken up, but at least let's have a look at it. Let's explore it, together. How far could we go if we were to push it? And I think that will be the next step of our work together.
So how does Noval Properties' vision for low-carbon buildings fit into this picture? And can you quickly, in a nutshell, give us a few of the examples that you're most proud of that fit into this vision?
Well, obviously, we're very proud about the sustainable buildings that we have. The Orbit office building, which, in my biased view, obviously, is the best office building in Athens. The Butterfly office building. We are now working, obviously, with Foster & Partners on Piraeus Street, and we are working on the grid, the former Kodak plot that we are developing together with Brooklyn Capital. And this is going to be a combination of an iconic design with a strong focus on occupier well-being. And it is something that we're trying to work, obviously, together with Viohalco about to get to a lower carbon building, and eventually, after many years, as David and Panagiotis have said, to a truly zero carbon building. This is the first steps of this process, and what we have done as Noval Property, as our first steps in this process, we recently acquired and stranded an old existing but not in use office building on Kifisias Avenue in Marousi, and we are now already started the redevelopment transformation of this building into a modern, into a quality, into a lower carbon, and what is going to be the first office building in Greece is going to be operationally decarbonized. So next year that will be ready, and we're very proud that we are taking those first steps that will eventually lead to a lower and lower carbon buildings, and at some point in many years, and I think David and Panagiotis have a much better view, how many years ahead is going to be to a truly zero carbon building.
So it is a long process, but it's important to get on track to achieve these goals. Mr. Skiadas, a final question to you. What does Viohalco's experience in manufacturing teach us about sustainable buildings? And are you optimistic, because you spoke a lot about realism earlier, are you optimistic about the prospects of reaching low carbon buildings imminently?
Okay, well, at Viohalco we have a wide range of products and production processes. Not only internally, but also the supply chain is very different. So what that has taught us is that we have to look at the whole life cycle of the production process. And we would only be looking at a very small percentage of our actual impact if we only looked at what we do within the boundaries of our plants. So we have to go back to the supply chain. That's why we mentioned that it's not only the operation of the building, but the actual construction. Now, having said that, looking at the life cycle of a material gives us the whole view, gives us the global view of the impact of the material. Now, when we look at a building, and if we can extrapolate that knowledge, we can see that a building is no different, it's only more complicated because it consists of so many different materials, not only aluminum and steel and copper, but a window can consist of several matters. A cable that we use can have 12, 13, 15 different materials. So this becomes more complicated. That's why it's difficult to go back and calculate, quantify the impact. Now, the building at the end of the day is the sum of all these. Am I optimistic? I am optimistic. I'm optimistic because, as I said, currently we have the technology, and with the smart design, with the automation and the proper looking at the whole life cycle of the building to minimize the impact during operation, which is currently the biggest contributor. It's the one that does have the impact. Now, if we can combine that with the behavior of the people, do we really want to wash our hands with such hot water? Hot water does have an impact. So combining our behavior, which is educating ourselves, and using the technology, we can really manage to minimize the impact. And then we have to wait for that limiting factor that I mentioned earlier. It's the extraction, it's getting those renewables out there, being able to really electrify all our processes, have the renewable energy, have the energy storage in place. This will not happen overnight. We need more than a decade to say the minimum, possibly 20 to 30 years. So once we do that, then we can really talk about a net zero building.
So efforts on multiple fronts to speed this process up as much as possible. Mm-hmm. Thank you so much for a very insightful conversation.
Thank you very much.
Thank you to our audience.